All right, so we're going to start with the derivative of sine x. Now, you may have it memorized, but we do just need to talk about graphically where it comes from. So this is not really a proof, but it can help you visualize the derivative of sine. Now, remember, when we say derivative, we're talking about slopes. So when I think slopes, I like to think little tangent lines. And if you picture little tangent lines here, I would say all these tangent lines are very positive until I get to pi over 2. Okay, and at pi over 2, if I draw a tangent line, and you should have one drawn in your notebook, I would say there is definitely a slope of 0. Okay, and then I would continue to say that all of these little tangent lines I draw are negative slopes until I get to 3 pi over 2, where again I can definitely say I have a tangent line or a slope of 0. And then I can say all of these slopes are very positive. So here's what we do. We are graphing the derivative. So we are graphing essentially slopes. So there is 2 really nice slopes. We said at pi over 2 we have a slope of 0, so I'm plotting that point, and at 3 pi over 2 I have a slope of 0, so I'm plotting that point. Now let's go back to the 0, in between 0 and pi over 2, and talk about those slopes. Are the slopes steeper? Are they getting steeper or getting less steep? And basically, I just kind of, picture like skiing on it or walking on it. Is it steeper here, here, or here? Okay, well clearly, to me, these are getting less steep because I'm getting closer to a slope of 0. It's a heck of a lot easier to walk up this part of the hill than it is this part of the hill. So I would say this slope is steeper and it's gradually getting less steep. So I know that this point is going to be much higher than this point, which is higher than this point. Okay, and I'm just estimating where they are, remember, but I do know that this is less steep than this part. Now as I continue down here, and again, put little tangent lines on there. Oops, I should use red. Where is it steeper? Are you steeper here or steeper here? Well, again, if I was walking up or skiing it, this is closer to 0, so it's less steep. And this is, obviously these are negative numbers, so these are more negative. And I would say right here, we have what we call a point of inflection, where it kind of turns, and it was all of a sudden, this was down, and now this is concave up. So it turns and becomes less steep again. Notice I'm getting closer to 0. So I would say this is as steep as it gets, and then it gets less steep as it comes back up. As I look at these slopes, again I would say less steep, steeper, steeper, steeper. So close to 0, positive and close to 0, and gradually getting steeper. So if I were to smoothly connect this, hopefully you can see that we have created the cosine graph. So I can officially say that the derivative, watch that notation, d dx, the derivative of sine of x is equal to cosine of x. All right, and we want to commit these to memory, and we want to know them by today. The derivative of sine x is cosine x. All right, this time we're going to look at cosine x and look at its derivative. So remember, 0 slopes are the easiest. How many 0 slopes does this graph have? I would say 3. Some people say 1, and that's the obvious one. Obviously, right here, I would have a slope of 0, so I'm going to plot that 0 point. But picture what you know the cosine graph is doing. It comes up to a max here and comes back down. So it also has a 0 slope there. And again, it's going to have a max over on this side, so it has a 0 slope there. So I know this is going to hit the x-axis 3 times, my derivative. All right, now look at your slopes. Let's put little tangent lines on. I have this tangent line, this tangent line, this tangent line. Where are you the steepest? Up here or here? Okay. Again, this is close to 0. This should be getting steeper. Now these are negative numbers, so they're getting more negative. So that's close to 0, and again, getting more negative. Right here is that point of inflection where it changes concavity. If you look at this side, it's concave down, and then it magically changes and is now concave up. So wherever that point of inflection is, that is my steepest point. And now you'll notice the slopes are getting close to 0 again. Okay, I'm steep, but now look, I'm bending, I'm getting close to 0, so this is moving up close to 0. Okay, now look at your slopes here. I would say this is a close to 0 slope. It's easy to walk on, but as I go, I'm getting steeper until I get to this point, and now I magically become less steep. So there's that second point of inflection here where it changes from concave up to concave down. So we can officially say that the derivative of cosine of x is equal to, notice it's not sine x, it didn't go up first, it went down first, so negative sine x. Alright, so we're ready to dive into our product rule. We're allowed to use the product rule when we're multiplying two functions. Now I can't stress functions versus coefficients enough. So let me get this product rule down. Okay, d dx is our derivative, that's our notation again. The derivative of f of x times g of x. Okay, notice I have a function in terms of x times the product, another function in terms of x. Okay, this is a lot of self-talk. Do not be afraid to talk to yourself, during a quiz, during a test, keep it low into yourself, but a lot of self-talk. I am saying it is the first term times the derivative of the second term plus the second term times the derivative of the first term. Okay? So, again, this is read f of x times g prime of x plus g of x times f prime of x. Now, truly, it doesn't matter if you did, the derivative of f times g plus the derivative of g times f. Addition is cumulative here. Okay, but, pick one and go with it. I'm going to say the first times the derivative of the second plus the second times the derivative of the first. Alright, before we actually do the product rule, we just want to be able to identify whether we need the product rule or not. Now remember, it has to be a function times another function. So let's look at one, and I can't stress, read these out loud to yourself. The more you say it out loud, the easier it will be. When I read example 1, I read 3x cubed. 3 is what we call a coefficient. Okay, it is not a function in terms of x times another function in terms of x. Because this is a coefficient and not a variable, I will not use product rule. Okay, again, 3 is a coefficient of x cubed. That's just a simple power rule. Number 2, I have the quantity, again, notice how I'm reading it, the quantity x squared plus 4x times x to the 6th. Okay, I could use product rule here because this term is a function in terms of x, and this term is a function in terms of x. So I could use product rule. I could also avoid it by just distributing, and again, I would prefer that, but I could use it. Number 3, I have 6x squared times sine x. Okay, 6x squared is no longer a coefficient because it has a function in terms of x in it. Sine of x is a function in terms of x. I must use product rule here. Two functions in terms of x. Number 4, I have 4 times the sine of x. Again, 4 is a coefficient. It is not a function in terms of x times the sine of x. This is not product rule. Alright, so I want to be very clear. You're using product rule when you have two functions in terms of x. Alright, exercises 1 and 2. Find the derivative of each expression. Now, watch my notation. The derivative of y is y prime. Okay? Now, do I have product rule? And I want you to always put parentheses around the things you think you're multiplying. I would say this says 3x to the 4th times sine x. So this is a function in terms of x, and this is a function in terms of x. So yes, we have product rule. Alright, so remember, it's first term times the derivative of the second, and we said the derivative of sine is cosine, plus the second term times the derivative of the first term. The derivative of 3x to the 4th, of course, is 12x to the 3rd. Okay, lastly, let's just talk about cleaning things up. Anytime you have, a coefficient or a single term, we like to pull it out front. So I would say y prime equals 3x to the 4th cos x. Again, I'm going to pull this term up front, this monomial, 12x cubed, and then, of course, sine of x. Okay, nowhere is it ever okay for me to multiply this times this x. Watch your parentheses. This is one term, sine of x. All right, let's try example 2. The derivative of h of x is read h prime of x. Anytime you take a derivative, make sure you have that prime in there like we talked about. All right, now, this has several terms in here. Let's start with 7x. Is 7x product rule? Is it two functions in terms of x being multiplied? No, it's a coefficient in x. So the slope of 7x, or the derivative of 7x, is just 7. Then I have a minus sign. Now it says x squared times cos x. Remember, read it out loud to yourself. X squared, parentheses, times cos x. Those are two functions in terms of x. So I have to use product rule here. Now, the ugly part is that minus sign. Notice I'm going to bracket in my product rule so I don't forget to distribute that negative sign. And I'm saying it's the first term times the derivative of the second. Notice I'm leaving terms in parentheses. The derivative of cosine is negative sine x plus the second term times the derivative of the first. Okay, notice every term is in parentheses. Now, be real careful on this cleanup. I'm going to clean up inside the bracket and then I'll distribute that negative. So as I write this term, this negative sign has to be pulled out front. So I'm going to say this is negative x squared sine x. You can't leave it inside because it looks like then you're subtracting. So just be clear that you always pull negatives out front. This is going to be plus, again, this coefficient gets written out front, 2x cos x. And then lastly, I just got to be real careful with this negative sign here and distribute it. So h prime of x is actually 7 plus x squared sine x minus 2x cos x. And there you have it. Next example, find the derivative with and without using the product rule and compare your answers to ensure they are the same. All right, so let's start with product rule. And again, this is a function in terms of x times another function in terms of x. So the derivative of f of x is f prime of x. Okay, and I'm saying it's the first term times the derivative of the second. So hopefully you're saying 2x minus 4 plus the second term times the derivative of the first. Now the next part, the calculus is pretty straightforward. It's first derivative of second plus second derivative of first. Now, the part where we mess up is in cleaning up our little algebra, so just take your time with that part. Okay, clearly this part has to be FOILed. So check my math here. I'm getting 6x to the 5th minus 12x to the 4th minus 10x plus 20. And this part is going to get distributed, of course. So I'm going to say plus 12x to the 5th minus 48x to the 4th plus 24x cubed. And then I'll just look for any like terms. And of course, like terms have that same base and exponent. So I have f prime of x equals, let's say, 18x to the 5th. I got a minus 12 and a minus 48x to the 4th, so minus 60x to the 4th, plus 24x cubed, minus 10x, plus 20. Whew. Now, remember, if you can avoid product rule or quotient rule when we discuss that, by all means go ahead. And that's what they mean in the second part. It says, find the derivative with and without using the product rule. So now, how would I do it without the product rule? Well, I would take that original function that I had and actually do what with it straight from the beginning. Hopefully just FOIL it out, you're saying. So let me go back to that, and let's just FOIL from the beginning. Oops. So let's see, if I FOIL this out, I'm just going to take this term and distribute it into each one of those. So I get 3x to the 6th minus 12x to the 5th plus 6x to the fourth. And then I'm going to take this term and distribute each one of those. Minus 5x squared plus 20x minus 10. Okay, and now I'm just going to take the derivative. It's simple power rule at this point. So I'm saying my f prime of x is 18x to the fifth minus 60x to the fourth plus 24x cubed minus 10x plus 20, and of course that derivative is 0. Now, look at that. That matches exactly with what I got from product rule. So if you can avoid product rule, by all means go ahead. Sometimes you just can't. Next example, find the equation of the tangent and normal lines of the function at the given x value. Now, anytime you see something about a line, whether it's tangent or normal, you're still saying to yourself, I need a point, an xy, and of course a slope. Now, your xy is typically your algebra, and your slope is your calculus. So let's say to myself, if I know my x value is pi, can I quickly go get my y value? Well, of course. Just find f of pi. Replace your x with pi. So I've got 3 pi squared minus pi times the sine of pi. All right, now I can't do much with this 3 pi squared minus pi, but what's the sine of pi? Picture that sine curve. The sine of pi is 0, which makes this times 0, 0. And that happens pretty frequently. So my point is pi comma 0. Now, to get my slope, that's where calculus comes in. I have to take the derivative. Remember, derivative means slope. So, if f of x equals the quantity, 3x squared minus x, times sine x. Okay, notice I'm reading it out loud. I'm stressing that word times. Do you have two functions in terms of x, or do you have a coefficient? Remember, a coefficient is just a number. So this function's in terms of x, and this function is in terms of x. So I got to go product rule. So f prime of x equals first times the derivative of the second plus second times the derivative of the first. So that's 6x minus 1. And don't be shy. I still say that every time to this day. First derivative of second plus second derivative of first. Now, at this point, there's really no need to write anything out or to multiply anything because you just want to know what the slope is when your x value is pi. So now I'm just going to evaluate f prime of pi. So I get 3 pi squared minus pi times the cosine of pi plus the sine of pi times 6 pi minus 1. Now you might be getting a little nervous because that looks extremely ugly, but remember these are trig values. And we already said that the sine of pi is 0, and 0 times this kills that, so that's nothing. And how about the cosine of pi? Well, the cosine of pi is negative 1, so I'm going to scratch that and put a negative in front and say that my slope is negative 3 pi squared plus pi. So now I'm ready to write the equation of my two lines. So the first one it wanted was the tangent line. And so that's going to be y minus, I think my y value was 0, equals my slope, negative 3 pi squared minus pi, times x minus pi, that was my x value. And my normal line, which is perpendicular to my tangent line, is simply going to be y minus 0 equals, I'm going to say negative, oh shoot, that was a plus sign, sorry. Negative 1 over negative 3 pi squared plus pi times x minus pi. Remember that normal line, you're just flipping and negating your slope. All right, and the next two examples, the last two here, this is the AP's favorite style of questioning. They love giving you all this stuff in function notation. So you'll notice it says find h prime of x and h prime of 1 given the following information. F of 1 is 2, f prime of 1 is negative 3, g of 1 is negative 1, g prime of 1 is 4. Okay, now again, I can't stress reading these out loud to yourself. It's huge in rewriting them. So I'm going to rewrite this first one. It says 3f of x, okay, minus, it's the term 4x squared times g of x. Notice how I'm just rewriting them in parentheses for myself. Now, I didn't write this first one in parentheses. I guess I could if I want. Let me throw that in parentheses. Ask yourself, do you have product rule or a coefficient? 3f of x. This is one function in terms of x. This is not. So remember, that's just a coefficient. So its derivative is not product rule. It's just 3f prime of x. That's simple. Minus, now I got to do product rule, so I'm going to bracket this junk in. And why do I need product rule? Because if this function is in terms of x times this function in terms of x. Talk it out loud. First, derivative of the second, plus second, derivative of the first. Okay, now I am going to clean it up. So I'm going to say h prime of x equals, I have 3f prime of x. Watch that minus sign. So minus 4x squared g prime of x minus 8x g of x. Okay, so again, I'm writing this monomial term first, and I distributed that negative. So it said find h prime of x, which we did, and now it wants h prime of 1. So all I'm going to do is replace every x I see with a 1. And I'm not doing anything in my head. I'm literally plugging 1 into every x I see. Whoops, that's a minus sign. I have 4 times 1 squared times g prime of 1 minus 8 times 1 times g of 1. Okay, and now I'm going to evaluate these based on that given information. So h prime of 1 equals 3 times f prime of 1, they said, is negative 3, minus 4 times 1 squared is 4, and g prime of 1 is 4, minus 8 times 1 is 8, and g of 1, they said, is negative 1. And if I clean that up, I get h prime of 1 equals negative 9 minus 16 plus 8, which I believe is negative 17. And we've got her. So they're not quick. They definitely take a lot of steps. Just take your time and lots of self-talk. We've got one last one to squeeze in there. Let me scroll back up there. Oops, I better recopy that one down. Alright, so I'm going to rewrite this function out before I try to take its derivative and just kind of separate things with parentheses. So I have 2g of x times f of x. I'm going to group the 2 and the g of x together because 2 is just a coefficient. So I'm going to say that's 2g of x times f of x. So I'm not doing any calculus, I'm just rewriting. Plus, I'm going to say that's 5x times g of x plus 7. Alright, and again, I'm just rewriting and cleaning it up for myself to see if I need product rule or not. So 2g of x times f of x. Well, this is a function in terms of x times something else with x, so that's product rule. And 5x times g of x is definitely product rule. This has an x and this has an x. And 7 is just a single term. Alright, so here we go as our product rule one last time. First, 2g of x times the derivative of the second plus the second times the derivative of the first. Remember that 2 is just there, bring it along. G prime of x. Okay, so I did product rule once. Now I got to have a plus sign, and I'm going to do product rule again. First, derivative of the second plus the second derivative of the first, of course, is 5x, and then the derivative of 7 is just 0. Whew, all right. Now that I found h of x, we want to find h prime of 1. So I'm just going to replace every x with a 1. So 2g of 1, f prime of 1, plus f of 1, 2g prime of 1, plus, I'm going to do that one in my head, 5 times 1 is 5, g prime of 1, plus g of 1 times 5. And again, just use those givens at the top. Alright, I've got 2, g of 1 was negative 1, f prime of 1 is negative 3, plus f of 1 is 2 times g prime of 1, 4, plus 5 times 4, plus negative 1 times 5. Hopefully that is correct. Let's see, h prime of 1. Again, feel free to pause whenever you need to. I'm getting 6. 2 times 2 is 4 times 4, 16 plus 20 minus 5. And I believe that adds up to 37. All right, so again, just take your time and just watch whether you need product rule or don't. Well, I think that does it for us tonight. Just, talk through it to yourself. First times the derivative of the second plus second derivative of the first. Hope you had a good time with our product rule, and we look forward to seeing you in class. Have a great night.